If you haven't printed this off, please do so now. We're going to talk about acid-base reactions. So these are just reactions that happen between an acid and a base. The name for an acid-base reaction is called neutralization. So neutralization just means when the reaction is done, the pH is going to be 7 or neutral. And the general form for a neutralization reaction is the acid plus the base forming some sort of a salt and water. Now, just a note here, salt does not always mean table salt, sodium chloride. It just basically means an ionic compound. Here's my example. I'm reacting hydrochloric acid with potassium hydroxide, which is a base. My product is KCl and H2O. So KCl would be my salt. So the hydrogen from the acid and the hydroxide from the base go together to make the water. The negative ion from the acid and the positive ion from the base go together to make the salt. So that's how the reaction takes place, but the general form is always acid plus base forms some sort of a salt and water. Now, because there's no precipitate being formed, there's really no visible sign that a reaction is occurring. So how do we know if a reaction has taken place or not? And this is where an indicator is useful. So an indicator is another chemical that we add to the solution that will change color once the reaction has finished. So I mentioned in a neutralization reaction, it's over when the pH is 7. So an indicator is some way of showing when the pH has turned to 7. Quantitative analysis. Remember, quantitative analysis is determining quantities or amounts, values. We can use acid-base reactions in order to figure out concentrations. And this method that we use in the laboratory is called a titration. So an acid-base titration is a laboratory technique that we use in order to determine concentration. So I will go through how this works with you in a minute, but first there's some terminology that you need to be familiar with, and it has to do with how do we actually set up a titration. So to run a titration, you have a setup like this. There's some different pieces of equipment. Here you have your Erlenmeyer flask, and this Erlenmeyer flask contains the solution of unknown concentration. So if you have a solution and you want to know what is the concentration, you would put a certain volume of that in here. Now you also have to include the indicator, a few drops of it in here. If you don't, then the solution's never going to turn color. You'll never know when the reaction is done. So you have your unknown concentration in here. You're going to add another reactant to your unknown through this. It's called a burette. So the burette contains the solution of known concentration. So I know the concentration of this solution, and I add it to, drop by drop, the solution that I don't know the concentration of. The indicator will change color once the reaction is done, and then I figure out how much of this known solution did I add. Then I can use stoichiometry to figure out what the concentration was of my substance in the Erlenmeyer flask. So don't forget, the indicator is added here. It'll turn color once the solution is neutral, and that point when the color changes is called the end point. We record the volume of our titrant, that's the solution in the burette, and then we use stoichiometry to figure out our unknown concentration. I'm going to do a demonstration here where I'm going to perform a titration of vinegar with sodium hydroxide, and my goal is to figure out the concentration of acetic acid in my vinegar. So the reaction that I'm going to do is I'm going to add acetic acid and sodium hydroxide together, so that's my acid and my base. The salt that will be formed is sodium acetate, and I'll also form water. So next you should watch the video of my performing this titration, and then I'll come back to this note and complete it.